All right, example 4, you would recognize this from chapter 2.1. We also saw a problem like this on the quiz involving, let's say, an arrow being shot in the air. All right. For the sake of you that still have to answer that question, I want it to be answered the way it was done in 2.1 for the quiz. All right. You haven't finished that problem, but this is using the stuff we're doing right now with slope. We can determine some of this stuff here. Because if I were to graph this equation, the y-coordinate represents its height in feet, and the x-coordinate, t, represents its time in seconds. So if I'm graphing this equation, which I'm not going to graph it, but if I were to graph it, and y represents feet, and t represents seconds, and I've got some graph, let's say, it'll look kind of like this, just for the sake of looking at what the graph would look like. If I found some slope on this graph, the change in y is feet, the change in x is seconds, so feet per second, you're looking at a velocity. All right? So if we can figure out the slope of this equation, we can then use that slope in order to determine velocities. All right? So with that in mind, let's look at the questions they're asking us. Find the velocity when t equals 2. When will the ball hit the ground? When will the ball reach its highest point? How high will the ball go? Find the velocity of the ball when it hits the ground. Okay, they're asking questions about velocity here and here. When will the ball hit the ground? That's a question of height. When will the ball reach its highest point? That's also a height question. How high will the ball go? That's also a height question. Okay? Some of these questions are pretty straightforward. Some of them are not as straightforward, so we need to do a little bit of thinking here before we do it. First of all, velocity. I just said velocity is what?
Feet over time.
Change of distance over change of time, also known as slope, right? So if I'm asked to find anything about velocity, the first thing I want to do is find the slope of that equation, the slope formula. So what we're looking at is a function f of t, which is 96t minus 16t squared. And I want to find the slope of that function. I'm going to use the slope formula, which says the slope is the limit as h approaches 0. Usually it's f of x plus h minus f of x, right? We're using f of t, so f of t plus h minus f of t all over h. I'll write my h approaches 0 a little prettier. There we go. All right. So I'm just applying the slope formula we've been using. Our function is f of t, so we do f of t plus this h, which is approaching 0, so these are almost exactly the same. Right? So 0 over 0, we're looking at indeterminate slope. So then we have to go ahead and determine this stuff. And f of t goes there, h goes there. The only thing we need to figure out is what f of t plus h looks like. So if I do f of t plus h, it's going to be 96 times t plus h minus 16 times t plus h squared. And as we've done so far in problems of this variety, I'm going to simplify that as much as possible. This is very much like we did on Friday. We have a polynomial structure, just a matter of simplifying the polynomial. 96 times t plus h is 96t plus 96h. T plus h squared is t squared plus 2th plus h squared. Distribute my 16 through, I'm going to get 96t plus 96h minus 16t squared minus 32th minus 16h squared. Be careful, that is minus 16, so that's a minus 16 being distributed through, so this becomes negative, this becomes negative. So if we consider the pieces of this structure, f of t plus h is this thing. F of t is that thing, and h is just h, right? So now if I just substitute that stuff in, my slope formula looks like this. The slope equals 96t plus 96h minus 16t squared minus 32th minus 16h squared. I'm in the room. problems is they get to be a little bit long. Okay, that's f of t plus h, right? I've got to subtract f of t, so it's going to be minus 96t plus 16t squared. I'm subtracting f of t, so minus each thing, minus that makes minus 96t and plus 16t squared, all over h. And that's the limit as h approaches 0. What should happen when you do it correctly with the polynomial function is the original structure, negative 96t, should have opposites. So 96t, those cancel. Positive 16t squared, negative 16t squared, those cancel. Everything in the original function should also exist in f of t plus h, so they cancel, getting rid of all the terms not containing the letter h. So at this point now everything contains h. There's an h there, an h there, and h there. That's h squared, but it's still h. So the slope becomes limit as h is approaching 0 of 96 minus 32t minus 16h all over 1. At this point, since it's over 1, if I substitute in 0, I don't have division by 0 anymore. So substituting in 0, all that does is make this term become 0. All the other terms don't have h's. So 96 minus 32t is the slope of this position function. All right? So anytime you get a position function, and that's what that is, a position, height in feet after t seconds, distance in miles after t hours. Any time of thing where the y-coordinate represents a distance, the x-coordinate represents a time, the slope is equal to the velocity. All right? And again, we have a formula to find slope, so we have a formula to find velocity if we have a position function. Is everybody comfortable with the formula there? So, I'm going to do a new page here just to have room. If we look at question A then, it says find the velocity when t equals 2. Well, the velocity is equal to 96 minus 32t. So the velocity at 2 seconds is going to be 96 minus 32 times 2, which is just going to equal 64, so it'll be 32 feet per second. Okay, that tells me two things. Number one, obviously it tells me the speed of the ball, right? Is the ball still going up or is it going down?
Up.
How do we know it's going up?
Positive.
It's a positive velocity. When you're in the world of gravity, you throw something in the air, as long as the velocity is positive, it's still going up. Okay, what happens when it starts going down?
Negative.
What happens before it starts going down?
0.
It stops. It's a velocity of 0. So for question B, and I'm getting ahead of myself here, look at question B. This has nothing to do with it stopping. Question B, it says when will the ball hit the ground? All right? We threw a ball in the air, right? All right? So as I let go of it, 96 feet per second, that's pretty good speed, just going like that. But anyway, 96 feet per second. When will it hit the ground is the question. What do we know has to happen when the ball hits the ground?
Stop.
Not necessarily. It's going to bounce, actually.
Oh.
But what do we know using either the height function or the velocity function?
Velocity slows down.
Okay, the velocity, when it hits the ground, is going to be the fastest negative velocity it can possibly have. As it hits the ground, it'll hit the ground, it's going to bounce. But as it's hitting the ground, its velocity is going to be very, very fast. So we can't say velocity is 0 when it hits the ground. Something else happens when it hits the ground, though, either about its height or its velocity.
Height is...
Decreasing.
Height is 0.
Height is 0 when it hits the ground, right?
Yeah.
It's on the ground, height 0. So when you look at questions like this, you have to ask yourself, what does that mean with the functions I have? I have a height function, I have a velocity function. Do I know anything about the height or anything about the velocity? When it hits the ground, its height is 0. Okay? So I want to know when it hits the ground, so I simply take the original function, the height function here, let y equal 0. If y is 0, it's on the ground, 96t minus 16t squared. Notice that's just a quadratic function with a greatest common factor of 16t. So if I factor it, I'm going to get 0 equals 16t times 6 minus t. Always look for factoring possibilities. Factoring is easier than quadratic formula if it factors easily. In this case, it does. Once I've got it factored, either factor A or factor B equals 0. What makes factor A equal to 0? This one.
0.
0. What makes factor B equal to 0?
6.
6. Which is the one where it hits the ground?
0.
6.
Why is it 6 instead of 0?
Because 0, when it hits the ground, it's the highest velocity.
0 is when I let go of it, right? That's the beginning of the problem. Then it goes up, stops somewhere, goes down, hits the ground. So the second time is the one where it hits the ground. So 6 seconds is the answer to part B.
What if it like goes up and doesn't come back down, just circumnavigates the globe?
Then you're dealing with a rocket science problem. We're not going to deal with that until this one.
Like blowing the water.
Okay. You're too strong, you can't throw the ball that hard. All right. We're going to assume that everything that goes up is going to come down. All right. Is everybody okay with part B? Okay, moving on to part C. When will the ball reach its highest point? So again, I have a height function, I have a velocity function. Okay? It's obviously asking how high it's going to be, when it's going to hit the highest point. So it has to do with height, right? Okay? When it hits its highest point, what happened to the ball?
Stop.
It stopped. So what do we know for sure at the point at the top of this?
It's equals 0.
What equals 0? Velocity equals 0. Very good.
Velocity.
So if they ever ask you about how high does something go, they ask you this a lot with these types of problems. You have to find out when it stops, because that's when once it stops, it's not going up anymore, right? It's going up, gravity's slowing it down. Eventually it's going up very fast, it's slowing down, slowing down, slowing down. Eventually it stops, then it starts coming back down. Where it stopped is its highest point. So if we set the velocity equal to 0, 96 minus 32t equals 0. So 96 equals 32t. So t obviously equals 3 seconds. 3 seconds after we let go of this ball, it stopped. All right? That doesn't answer the question of, or it does answer the question of when the ball reaches its highest point. It reaches its highest point at 3 seconds. It doesn't answer how high it will be, right? So for part D, it says, how high will the ball go? What we're going to find out is where it's at, right? When it stopped. Okay, so we go back to the height function, and we let t equal 3. So we're going to get 96 times 3 minus 16 times 3 squared. I went ahead and squared 3 on my head. 96 times 3 is 288. 16 times 9 is 144. Subtract, we get 144 feet. So if you can throw a ball 96 feet per second, again, that's pretty fast.
Straight up.
Let me get that in miles per hour real quick.
That's nothing.
$65 miles an hour.
How fast is
That's doable.
Straight up though?
Yeah, well, yeah, straight up, might throw out your rotator cuff or something. But anyway, 65 mile an hour straight up. You should expect the ball to go about 144 feet, because negative 32 feet per second squared is the gravity of Earth, and negative, or you take half of that gravity in a position function. So that's where that's going. So 144 feet is how high the ball would go. Part E, find the velocity of the ball when it hits the ground. This gets back to what Tyler mentioned earlier. When it hits the ground, what's its speed?
0.
No.
Oh.
As it's hitting the ground, as it's making contact. So it got thrown up in the air, right? And it's coming down. As it's making contact with the ground, it's going pretty fast.
Height is 0.
Okay? Its height's going to be 0, but its velocity is what we don't know. When does it hit the ground?
3 seconds.
No, it's 6 seconds, right? We already answered that question. It hits the ground at 6 seconds, so we want to know the velocity at 6 seconds. So if I just let t equal 6 right there, velocity at 6 seconds is going to be 96 minus 32 times 6. That's 96 minus 198, no, 192. That's negative 92 feet, no, can't subtract here, sorry. Negative 96 feet per second. Does that look familiar?
Yeah.
How fast did the ball start? What? It started at 96, right? We threw it up at 96 feet per second. It hit the ground at 96 feet per second the other way, negative, going downwards, okay? If there's no friction, whatever speed something goes up in the air, the initial speed it starts at, the speed it comes down, that's the exact same speed. because of friction, sometimes they get slower. There's what's called terminal velocity that something can reach, depending on its shape and how much friction is slowing it down. But if there were no friction, if you were to shoot something in the air, when it comes back down, it's going just as fast. All right, and some people don't realize that. So be careful of that. The reason that it had happened, that it was the exact same going up and coming down, is because it started at 0, ended at 0, right?
Yeah.
If you're doing it off a cliff, you're starting here and then you shoot it up and then it lands way down at the bottom of the cliff. It's actually going faster when it gets to the bottom than when it passes by you. It's going the same speed, but as it continues to go down, it continues to speed up. Again, based on no friction. If there's friction, it could actually not hit a maximum speed. We don't have friction in calculus problems, so everything is theoretical, and we believe that everything is frictionless. So we're going to get this happening all the time.